I'm Scott McKean. I'm currently a data scientist with Chevron. So I moved over there after working as a data science intern at CNOC. And before that, I had a relatively long bit of experience in what you'd call like traditional engineering consulting. So I do like environmental and geotechnical project management and engineering. So that was kind of my background. I still identify mostly as an engineer, but I'm getting into this data science stuff and it's really interesting. So I'm loving it. And the reason why I'm here is that I think every engineer should know how to code. I think coding really like changed my life. Without learning to code, I wouldn't have the positions that I have today, and they're awesome positions. So hopefully you guys are interested. And if you're listening to this on the YouTube channel, we'll try to keep it relatively brief. And hopefully this helps kind of instruct you on how to get started with coding. Okay. I'm gonna share my screen, and I'm just gonna share my entire screen. It's a bit easier. Okay. And let's get started right from the basics. Now, I'm assuming that if you're here, you're going to be participating in the bootcamp. So I loaded up some of this energy data set that we're going to be playing with. But first, let's get started with how you actually access this material and load it up, and just talk about R and RStudio and maybe how it compares to Python really briefly. I'm going to cover a little bit of coding, but here's the dirty secret about programming and coding in general is that really this is how I do a lot of my coding. I will open up a browser window. I'll probably Google or Stack Overflow and look up things, and I'll be coding in parallel because there's so many things to remember when you're doing coding, and it's all in the internet. That's the kind of the beautiful thing about open source programming and data science in general, is that people write about it. So if you want to learn how to code, just start. And I think that's why boot camps are so good, because you can kind of get this like critical mass, and then you go and do these hackathons where you just try it out, and everyone's at a different level, but you just do what you can, right? So let's get started right from the basics. So I put up, let me just minimize this. Sorry, guys. Okay. Okay. I'm gonna minimize this, drag it down, perfect. So I put all of the material for this bootcamp up on my GitHub account, and GitHub is a version control, provider that allows you to do commits and version control your code. It's also how pretty much everyone distributes their code. There's a couple of version control providers, but Git and GitHub are by far the vast majority. They definitely have like won the race. So if you're looking for stuff and you're looking for how somebody else has done it, it's worthwhile to take a look on GitHub and do a little search. So the bootcamp is located on my account. So Scott H. McKean /ASEC 2021 R bootcamp. And in there's data, a permissive license, and 3 R Markdown folders. So without going into Git or anything, all you have to do is where it says code, pull this down and just download the zip, okay? And I moved that over onto my desktop. So if I zoom in here, you can see that I've opened this folder and it looks exactly how you'd expect it to look from here. So I've got this data, I've got 2 CSVs. We'll go into that later. And I have 3 R Markdown documents. Okay, and the first one you want to open up is this R Foundations. Now, I wrote this and it's a really basic introduction to some of the things that I think are really important in programming, and specifically R. So I'm going to expand this. If you guys have any questions, please stop me, okay?
I'm sorry to interrupt. Could you send the website link on the chat?
Yeah, sure.
Thank you.
Yeah, no problem. Sorry, I'm absolutely horrid with Zoom and it's kind of tiny. Okay, so did everyone get that?
Yes.
Okay, so yeah, if you go to there, you can download the code. So then I'm in this R Foundations. Let me know if anyone has any problems. Now, I'm opening this in a program called RStudio. And I think the first thing you have to do if you're going to try to understand R is understand that R and RStudio are different. They're not that much different, but RStudio is an interactive development environment, whereas R is the programming language itself. So on the Python side, you might download an Anaconda distribution that has a Jupyter notebook and a Spider, but Python itself is a language and it's generally installed on everything. And there's so many things built on Python, so many things built on R, but that's the language. How you access the language is always separate in pretty much every programming language. So in here, I just talked about, you can look up a little bit about R on this link, and you can look up RStudio here. So in order to get started with this workshop, I'm hoping that you've already installed R and that you've already installed RStudio. If not, just follow along. If you have questions, feel free to ask. But the best way to learn is by actually doing it. Now, I put up 3 references here that I think will get you started really quickly. One, I learned so much by having a subscription to Medium for a year when I was kind of getting into data science. That's where sort of everyone publishes blog posts on data science, and they'll generally like cross-link to blog posts. And it's sort of this like, you get a small amount of money for publishing interesting things. And if people like it, you can maybe make $5 or something. So you have a ton of people that write things, and probably not so much for the money, but because they're really interested in it. Next, Hadley Wickham has, I think, kind of revolutionized R, and it's not just Hadley Wickham, but Hadley Wickham and his like cohort of people. They have developed kind of what they call the tidyverse universe. And I think when we talk about R, there's almost 2 completely separate types of R. There's like Hadley Wickham, RStudio, tidyverse R, and then there's base R. That's really important to understand. I only subscribe to the kind of the tidyverse side of things because I think when you're passing along code as an engineer and you're doing engineering projects, code needs to be super clear. And so if you're going to be doing this for class projects, you're going to be doing it as you enter into the work world. I really recommend, if you're going to be starting to like deploy code, learn how to do it properly and cleanly. And I think that the tidyverse is a really beautiful way to do coding. One book especially, if on this link, is R for Data Science. If you read that, there's a treasure trove of information. It'll get you started really well. And lastly, I took both data camps like Data Science for R and Data Science for Python boot camps, and I really liked them. I thought it was a really well-designed way to learn, especially for people that are busy and kind of just beginners. It takes all of these like pretty overwhelming tasks of like doing programming, and it encodes it in the browser and kind of gets you started, and then it error checks things that you're doing. And one of the, I think, the really frustrating things with learning to code for the first time, beyond kind of having your hand held through your C++ class, is that you're going to be making all these mistakes and you don't know why they're happening. And it's a really hard thing to Google. So you can't just Google, hey, my code isn't working, please tell me why. Now if you have a specific problem and you know specifically how to Google, it starts working, but you need to get up to a critical mass. And so I'd really recommend trying like one of these lighter boot camps. You don't need to do anything too crazy. I really like Data Camp because I think it's really easy, but there's a lot out there. So have a look. That's kind of like my opinionated references. Any questions on that? Nope. Okay, we'll move on. Okay, when we talk about open source programming, what we're really talking about is packages or libraries. And if you're gonna try to be successful, even with this hackathon, you need to know how to install packages and how they kind of work. And so I guess there's like 3 things, right? Google it, look at CRAN, and then there's a really stupid word that they use in R called vignettes. But they're really, really great for documenting packages. So I just clicked on this link, and these vignettes are stored on CRAN, which stands for the Comprehensive R Archive Network or something like that. But what you can see is that these vignettes provide an example of how to use the package, okay? And they have R code embedded right in them. And so generally the workflow for using open source programming software, whether it's Python or R, is you say, hey, I have a problem. One, I think this problem can be solved by this existing solution. You go and grab that existing solution, and then you figure out what the API or application programming interface is for it. So hopefully that makes sense, but generally you say, okay, I need to be able to organize my data. And so you say, search organize data, organizing data in R, or we'll go over that in this bootcamp. And then you'll look into it and be like, oh, there's like the tidyverse has this package called deployer, and there's a vignette for it. And so it basically says like, hey, this is what this package does. Here's how you use it. You can describe things, and then there's all these verbs that we're going to go through in this bootcamp. And you can say like, okay, this is how you're going to sort rows. This is how you're going to choose rows by position, filter, do all these things. And they're incredibly useful for trying to learn how to use things properly. Hopefully that makes sense. Okay, so the first thing that we're going to do is just install a library. So if you notice, if I press play, this is an R Markdown document. And did you guys want me to explain a little bit about R Markdown and how that works first?
Sure.
Sure. So R is a library, right? So if we're looking at this, this is RStudio's sort of default layout. Okay, there's 4 main panes. There is your code, and your code can either be written as an R script or an R Markdown document. And if you are familiar with Python, Python has Jupyter notebooks. Jupyter can actually run R as well, but generally RStudio it's such a good IDE that almost everyone that uses R uses RStudio, and it's kind of a match made in heaven. So I'd really recommend, if you're using R Markdown documents, do it in R Markdown in RStudio. But there's 2 things that you can do to program. So you can make an R script, and this is just what you kind of expect. So you can go like write library deployer, and then you can write 2 + 2, and you can print 2 + 2, right? And so you can run these, and you can see that basically it's going to load some things, and it's going to print back 2 + 2 in the console or your terminal. So that's the first thing is your script window. The second is your console. Over here, this is what one of the things that RStudio is really nice with is that it has an environment. So if I go into a notebook, I can load packages, and then I can also create all these chunks, right? So if I just hit enter here, you go 3 little quotation marks, type in R, and I can assign something. So I can say X is equal to 2, and you hit Control Enter, and you can see what's in your global environment that pops up. And then you can say Y is equal to X, Control Enter, and you can see that now it's taken Y, it's assigned it is equal to X, and it has a value of 2. I'm going to go through a couple data types really quickly too, but just so you know, like that's one of the really nice things about working with an IDE is you can see your variables. Whereas if you're working kind of with scripts and just running them, it's really hard to know how things are changing, how they look. And generally, if you want to use R, you're using it because you're using what they call a data frame, which is just sort of an Excel table in memory. And you kind of want to be able to expect that. You want to inspect what the columns are. You want to see what the names are and get some information about it. So this is really useful. Down here, it just gives you an example of help and some, I guess, generic things. So you can see some plots, you can look at files. If you wanted to look through here, there's a little bit of a browser. Your plots will pop up there, you get your packages, and this help is really useful. So remember that I was telling you about those vignettes? Well, every package has documentation. And if you were to build a package, you can write this documentation, which I've done before, and it's really useful when you're sharing code between people. But for example, here, there's a function that says like, okay, we're going to read this file, a quick description and usage information. And all you have to do to get that is you can just go Control Enter Help Deployer, and it'll tell you about how to use some of this stuff. And then each one of these packages, so they have a whole bunch of functions. And so say if you were wondering about this, you can just go question mark, Control Enter. and you'll see it'll pop up this information about this function. And I can see that already it's superseded. So maybe there's another way that they want us to do this and kind of how the usage should be. Does that make sense to everyone? I know I'm running really fast through all these concepts, and I think in 2 hours, I didn't really have much of a choice. So it's going to be kind of like fast and furious. Stop me, please, if you have any questions, okay? Okay, well, I'm going to keep plowing on. Interrupt if you found something confusing, and we'll just keep going. Now, remember at the beginning of the talk, I was telling you a little bit that there's like this base R, this tidyverse. Well, there's another package called data table, and there's almost like there's 3 tribes. Now, these tribes of R programmers play along really well, and like tidyverse and data table are built on base R. But you're going to hear it if you get into the R world. Somebody will be like, oh, you're using tidyverse. Why don't you use data table? Here's the difference. Base R has data frames. It has data structures. Same thing that the other 2 packages have, but it's a little slow. It's a little bit clunky, and it's not as beautiful as, say, tidyverse. Now, tidyverse, I'd say, is like the highest level way to access R, and it's what I'm teaching exclusively in this bootcamp because I think it's an awesome way to learn data analytics. I think it's probably the best way to learn data analytics. So thank you for joining me. And then there's a package called data table that it's a lot less accessible, but it's ultra fast and it's ultra concise. So if you like really concise code, you don't like being verbose, then it's probably the best thing. If you just wanted to hack straight for speed, then take a look at data table. And I'm going to show you an example right here. So just to give you a bit of terminology, okay, this is a chunk. So when we talk about a markdown file or a Jupyter notebook, they're in little chunks, and you can run these chunks one at a time, pressing these little play buttons. So I can press play to run the whole thing, or what I can do is I can run it individually at a time. So if I go Control Enter, boom, that'll run that single line, Control Enter, all the way down. So I'm just going to run this all, and then I'm going to walk through and explain what it's actually doing. Okay. So first thing I'm doing is that R comes with these pre-packaged data sets. So if I go cars underscore data frame, you can see that I have 50 rows with just speed and dist. Okay. And if I look here, speed, distance, these are columns. And then generally the idea of data frames is that all of your features or variables should be in columns and all of your observations are in rows. This is really important because that's how a lot of this stuff is structured. So you should always be seeing columns and features going this way and observations down. And then if you look into your environment, you can see, okay, we've got this data frame. I've got a column called speed, a column called distance. They're both numeric. And if you're from the C++ world, that's like a double precision float. But yeah, so you got numerics. And then you can also call these nice summary functions, which gives you sort of your statistics. And you can call a head. And this head is same as Python, but it just gives you the first certain amount of rows. So this one gives you your first 6. Now, if I wanted to subset and I wanted to say, okay, I want to grab this data and I want to filter to a certain thing, and then I just want to pull out the distance column. So like speed versus distance. And what I wanted to do is say to grab speed is over 4 and then pull distance. I can do that in base R doing this. So cars is a data frame, okay? And this data frame has rows or observations and columns. So I'm going to say I want to take every row where the car $ speed is above 4. So that's saying, okay, take this car's data frame, access, that's what the $ is, this column called speed, and make it over 4. So if I copy this out, you'll see that it actually gives me this series of Booleans. And that's how, whether you're using Python or R, that's how we filter things. We generally make this Boolean mask and you put it over top of a data frame and you say like, hey, give me every row where speed's above 4. And then you have your column accessor here where you say, okay, well, then give me the distance column. And that's what it'll give you. And it gives you it not in a data frame, but in an array. And so down below, I've talked a little bit about like data types, data structures, but really the only data structures you need to know for this little hackathon that you're doing, and the vast majority of the work we do, are an array, a data frame, and a list. So a list being a generic container for a whole bunch of stuff, a data frame being a table, a structured table of rows and columns, and an array just being a sequence of numbers. And generally a column is stored as a sequence of numbers. So when I pull that out, you can see this here. Okay. Now, in Tidyverse, they have these things called pipes. So if you see that there's this cars data frame and we're using this pipe, what I can do is I can go like that. Oh, let me just import deployer there. And that imports this pipe function. Now this is a special function that they use. I really like it. If you have programmed a lot before, you might hate this because generally, if you're used to programming C++, it's going to be like, do this to that. And you get these like nested functions where it's like, and you read inside out. I think that's actually, that really hurts readability. And when I'm talking with non-programmers, and even when I'm talking with programmers, I find that really hard to debug. And so the one thing I love about Tidyverse is that you pipe everything and it is really explicit. So you say, okay, I'm going to take this deployer package and I'm going to pull distribution. And then I'm going to do this to that. And when we talk about, deployer says that they provided a grammar of data manipulation. And so they provide it as verbs. I really think that's a really nice way to think about how you're doing stuff. And if I pass this to somebody, even if they aren't a programmer, they can read it. And most engineers have a pretty good background in numerical analysis. And so if you explain to them, you're like, oh, I'm going to filter, and then I'm going to pull this column, and then I'm going to do this to that, they'll get it. And you can actually, I've done a lot of, say, data science-y reviews with engineers, just going over code that looks like this and saying, okay, we're going to do this. And then they'll say, oh, actually, that, I don't know if that filter makes sense, or I don't know if we should do that, or this, or that seems a bit aggressive. It's a really nice way to work, which is why I really like it. So to do the same thing that you did up here, it's a lot more verbose, but I can run that and it gives me the exact same answer. And then in data table, I have to declare this as a data table because it changes the structure a little bit. It's a really smart package. And then it's the exact same thing. So very similar to this, to base R, but it's about 100 to maybe 1,000 times faster because it's all done in memory. It has a nice C backend. So did that make sense to everyone? I know we're kind of like throwing the fire hose at you, but does that make sense for everyone so far? Okay, I will just keep going. Okay. Two things that I really wanted people to understand as we get going. So there's two big, I guess, paradigms you need to understand in programming. One is static versus dynamic type language. Static languages are compiled and then run. So when you did your C++ course, and I think they're still teaching C++, and maybe they've moved to Python at U of A. U of C is still teaching C++, but C++ is a static language. It's really fast, but you need to compile each little thing at a time. And so it changes how you program a lot. And the reason why people really like Python is that it's dynamic. So let me give you an example. if I'm trying to say, okay, A is equal to 2, the minute I run that line, it goes into my memory. And so I can bring that up, it's 2. And then I say A is equal to 3. Okay, I override it. I can declare that B is equal to A, set A is equal to 5. And so as you're changing things, it's updating everything in memory. Now, just be careful though, right? So you've declared B is equal to A, and then you update A. Now, here's a really big difference between R and a lot of languages like Java or Python. R makes a copy of almost everything. So if you're using R for something pretty heavy, you better make sure that your computer has a lot of RAM, a lot of memory, and you are pretty safe. But in Python, it uses a lot of what they might call like pointers or references. So if I were to do this in Python, A and B would actually be 5, because you change A, B is referenced to A, and it would give you 5 and 5. So that's one difference that really gets people. And then the static to dynamic, I think sometimes gets people in the style of programming. I'd really recommend, if you're going to learn programming, do a dynamic language and just start hacking, like just start working on something and running it until it fails over and over and over. And that's why I think Python's so fast relative to some of these other languages. When you're actually coding it, because you can just run things over and over and get it to fail, fix it, and run through things. The next thing that I wanted to talk about now in this hackathon that you guys are going to be doing, this is mostly philosophical, but if you get into programming, it's worth paying attention to. There's 2 paradigms for designing programs. One's object-oriented and one's functional. Functional, I think, is what us as engineers should focus on when we're learning, but you'll read a lot about, say, object-oriented. And in this object-oriented approach, there's some big advantages to it, but it can be very confusing. And the main difference is that you want to link things in a functional approach together. So I kind of made a little functional program here, where what I did is I built 2 little functions. So I said feature eng this, and then ad hoc clustering is this. So I said, okay, when this meets these criteria, assign it 1. If it meets these criteria, assign it 2, else assign it 3. This is, I think, a really nice way to put some sort of like logic. But what this does is I can run these car features and just apply this function. So speed dist is just, I take speed and multiply by distance, and I add it to the original data frame. So let me zoom this down a little bit. So if you see this car's features, I use this mutate to add something in using my own function. And the beautiful thing about functional programming and engineering is that every single one of these functions you can test. And that, I think, is really important if we're doing mission critical work, or if you really need to understand how something works, you can write tests and you can really understand each little bit of your function. Whereas in object-oriented programming, you have this idea of polymorphism. So I guess the classical idea is a car, and then a car has a wheel class and then an axle class, and you build this all up and it builds into a car. But the car could be a Ferrari or it could be a Chev, and the wheel class should be the same. So it's this paradigm they use to build up these really complex programs. It's really hard to learn well, is maybe my recommendation. So I really recommend that you look into learning a functional program, and then you can do stuff like this. And I think it's really readable and really nice. So I can put in these functions, and then I put in pipe, and I do this ad hoc clustering. And you can see that I've assigned all these things, and you can really read it. And I think it's really straightforward. Okay, last little bit that I'm gonna cover. Hey.
Sorry, just a question about the previous one you did, not about the object programming, but the one before where you reassigned B is equal to A.
Yep, up here.
Yeah. So how come B didn't change? Or like, I didn't really get the difference between static and dynamic.
So is it Yasser or Yassir?
Yeah. Yes, sir.
Yassir?
Yeah.
So in Python, to get the same behavior here, you need to go B is A dot copy. Okay, I don't know if you program Python or not.
Yeah.
But
yeah.
the difference between, I guess, the static and the copies are almost two separate things. So static and dynamic. Static, you compile stuff and then run it. Dynamic, you can just run things one line at a time. So let's separate those two. Does that make sense to you? The static
Yeah,
versus
that makes more
dynamic?
sense. Yeah.
Okay. Sorry, I should have maybe put something like, okay, this and then copy versus reference, right? And what I was talking about here is that in R, you generally, every time you do this assign, it makes a copy of the object.
Okay.
Now, in Python, it doesn't. It does a reference. And depending on the language you're programming in, it changes. Like it's kind of one of these like fundamental things to each language, whether you're going to use a reference or a pointer and say that like when you assign something, they aren't two separate things. They're the same thing. And then if you change A, B will change too. In R, that doesn't happen. So in R, if I assign A is equal to 3, right? And then do A and B, right?
Right.
It'll be the same. But then, so then I'm going to run B is equal to A. So then I'll set B is equal to 3, change A, and you'll notice that now A is 5 and B stays as 3.
Right.
If you did this in Python, it wouldn't be like that. They would both
To be
change to 5.
5. Yeah.
Yeah. And I think that's just really, that's super confusing for people when they start out. So I just wanted to kind of throw that out as a caution.
Yeah. No, thank you. Thanks.
Okay. Yeah. Thanks for asking a question. This is a bit advanced, I know, but just to let you know that like these functions are really great and you can put them in these mutate verbs and they're really useful for doing like feature engineering. We're going to use a couple of them in the notebooks. And then the last thing, I talked about this already, but I think there's three data structures you need to know when you're programming just to get started. The first is a list, okay? And a list is this unorganized thing. So if you wanted just to like lump things together in this object that you can pass into things or save things and then write it out or what have you, and there's difference, like one might be a scalar, one might be a data frame, one might be an array, you can put those together in a list. But when you have an array and a data frame, they're structured, right? And so here's an example of a list. And if I pull this out, you can see that 1 is the speed column. And if I go 3, it's actually a string. And that's how I declared it. So I declared 2 arrays in a string. And depending on how you change it, you get different things, right? So that's an array. That's an array. But I could have also put this as a data frame too. So it's handy if you're doing a container that you just need different things, right? And if I were to just call the whole list, what you can see is the first one is an array, the second one's a data frame that it pulls up, and the third one's a string. Not really useful unless you're building programs. And if you're trying to pass things into functions and you have a lot of things to pass, you want to make the data structures a bit more complex. I put some, I guess, recommendations is that if you're going to be doing a function or you're like building some things up, try to be as simple as possible. And that's kind of a general recommendation for all of programming is that if you're going to try it, try to go as simple as possible first and get it running. And I've been bit by this so many times is that you have this really great idea and you're like, oh, I think I can just make that work. And you try to shoot for the moon right away and you try to get this really impressive thing done. And it never gets there because it's too complex and you can't debug it. So you need to really break it apart into like the smallest chunks you can think of and then build it up from there. And in this hackathon, that's what I'd really recommend too. And we'll dive into that a little bit more. Okay, just to finish off, an array is really useful because it's an array of numbers and you can declare an array of numbers into a data frame. And then here, you can basically build up a sequence, and it's worth just paying attention to how this is base R, so data frame, and I'm declaring 3 columns, X, Y, and Z. And if I look at it, I think it's worth just paying attention to how this data frame looks. Oh, by the way, if you click on one of these IDE things, you can actually pull up the table to fully look at it, which I think is really handy in RStudio. It's really nice when you're looking at stuff and you can scroll it and search it and do some things. Like I can filter to say, y is equal to 2 and 3 really quickly. But point being is that I declared the first variable as a sequence of 1 to 5, and then I passed in scalar values. And so what happens is this data frame broadcasts these scalar values right across the data frame. And so when you actually look at it, it's still 5, but it says 2, 2, 2, 2, 2. And then this is actually encoded as a factor, but I won't get into that too much. Okay, that's kind of it for our foundations. I wanted to dive into the more interesting stuff. Does anyone have any questions to get them started with using R? Okay, let's keep going. This should be a little bit more interesting than some of the foundation stuff. So I'm going to open up the second file in the bootcamp, and it's going to be called data munging. And I'm going to go through a bit of this. We're going to get to where we get for the end of this workshop. And then the next workshop tomorrow, I'm going to cover data munging and forecasting. I tried to make this really applicable to the hackathon to hopefully help you guys out. So I hope you found it useful. Now we're going to dive right in. So I'm using a completely tidyverse style. I think it's readable. We talked about that a little bit. So I hope that's all right with everyone. I'm going to be using these packages. So in order to install a package, I think I have all these installed, but if you call library, and let me just see, trying to think of a library I haven't installed. So if you say like, okay, there's no package like this, you can go and call this function called install packages. And then in quotation marks, you can type it in. If I wanted to install tidyverse, which I think is depreciator or deployer, this will give you a warning, say like, okay, you've already had this loaded. I'm not going to restart R, but so say I'm going to call this R mass package. What it'll do is it'll go onto CRAN or the R package repository, and it'll look and it'll say like, okay, it's not available or it is available. So yeah, if you just search, make sure it's in quotation marks, and you should be able to install things really easily. I generally haven't had a lot of problems. And if you have a fresh install of R and a fresh install of RStudio, all the packages that I'm using should be relatively easy to install. So hopefully that goes okay for you guys. If not, Google, see if there's any problems. You can just drop me a quick line if you have any problems or anything. But yeah, let's get into it. So the first thing we need to do is on the hackathon, we're going to be using, and Remy, correct me if I'm wrong, but we're going to be using this energy demand data set. Now I pulled this off of Kaggle. So I went in and just pulled the data set. And the first thing I need to do is read it into R. So let's start there. So I'm using the reader package. And this reader package has this function called read CSV. There's also a base function of read CSV. I find this one's faster and just a bit better. And so I'm going to just clear off my environment. This little broomstick clears it off. Okay, first thing I'm going to do, I'm going to run reader read CSV. And this loads in this energy data set. And then by dropping it down, you can actually see all of the different columns as they're loaded in the CSV, the type of columns. So, and the reader package is really nice because it can parse a lot of the dates. And so one of the biggest problems with bringing something in from CSV or Excel is the dates don't read properly, or things that are strings get read as factors and like the data types aren't right. So pay attention to that. But like I said, you can just scroll down, read all these columns. We're going to be working a lot with this total load forecast and actual, but you can see that we have 35,000 observations with about, I'd say, 29 variables. So you can see the time of when this was recorded, how much was generated, the total load forecast and the total load actual, the price the day ahead, the price actual. And so you can do this is what we're going to be using to do our forecasting challenge. So then there's a couple different ways that you can get some summaries of this data. First is you can call head. Okay, and this head can basically go and you can look at, okay, here's the first couple of things. How are they looking? You can see that this is all NA, so there's no storage. You look through, these are all zeros. This looks interesting that it's 43 across the board. Nuclear looks really consistent. So you can just have a really quick look to make sure your data makes sense. You can call
Scott,
dim. Yep.
is there a better way to visualize like the table? Because I know in Python you can, if you call in like dot head or tail or whatever, you can see it like a lot of columns instead of like scrolling through.
Yeah, it depends on how you have it set up. So you can do like your summary here. You can do your structure. If I'm visualizing the table, I'll generally just double click. Oh, sorry, it's just churning through. And I'll look through it this way. I know that when you're using Jupyter Notebook that it cleans it up, but
Right.
generally if I'm looking at it, I'll just pull it up into the browser. I'm just
Okay.
kind of like looking at the table.
Right. Okay.
Yeah, it's not the prettiest. I think there is a prettier way to bring it up if you Googled it, but I generally don't do that a lot. So
Okay.
if I'm trying to visualize, I'll probably go straight to histograms or doing some Ggplot, which we're going to cover really quick.
Okay.
This STR, the structure, is really nice. It actually is exactly what you see here, but it gives you like how many NAs you have and some of this stuff. So yeah, so you can do that. So I like, when I look at a data set, first thing I'll look at is I'll grab the column names, especially if there's things like this, that when I'm trying to call things are gonna wreck my life. And then I usually just call it. So this is, the column names are really big in this one, but this is actually just sort of the tidyverse RStudio way of visualizing. So you can go through, look at this, you can, yeah, I don't know, that's how I kind of visualize most of the time. There's a second data set called weather, so you can load that in. I'll shrink this one down. So this is 178,000 rows of 17 variables. I think this is where it starts to be really nice to be using something like R as opposed to Excel, because R can load in 1 million rows, no problem. It's not going to cause it a bit of heartache. I think once you get past about 50,000 rows on Excel, it starts to bog down. The newer Excels are much better and they've done a lot of work to improve it, but still. And then you have a lot more control about your data in here too. Once again, we can call summary, get a good idea of all the columns, how many NAs there are. I really like summary because it gives you like, okay, this is a character. Here's your quick summary stats, like, and if there's a whole bunch of NAs, you're going to see it kind of right away. And then we start to get into data munging right away. Okay, so maybe the first like question I might ask is like, okay, so it looks like there's a whole bunch of city names, but what cities are in the data set? Right. So if I was going to do that in Excel, I might auto filter and then like do the drop down to see what's there. But it's actually really nice. You kind of tell tidyverse or R exactly what you want to do. So in this one, I take it, I say, okay, take city name, turn it into a factor. Just make sure that it's right now it's a character. Just make sure it's a factor and just show me the unique values. And it says, okay, there's actually 4 cities. Boom, done. Right? Or 5 cities. I don't know if Barcelona and Seville are separate, but I think there's only 4. So by factoring it, you basically can take all of this and turn it into something that's a lot easier to deal with if it's a categorical variable as opposed to a character. It's unique function is really nice. So even if you didn't turn it into a factor, you can see that there's 5. So Valencia, Madrid, Bilbao, Barcelona, and Seville. Hopefully that makes sense. Now, the next thing is that we want to make sure that our data is nice and tidy. I put some stuff about tidy data here. Fortunately, both of the data frames that you're using in this hackathon are actually very tidy. They don't need a lot of cleansing to them, which will be really nice. But what I might want to know is these are already in sort of long format. But once you have a nice tidy data frame, you can do some really impressive things right away. So what I'm doing here in 4 lines of code is I'm taking weather, I'm making a histogram of temperature with 40 bins apiece, and then I'm using this thing called facet wrap to split it out by city, and then so I can show temperature. And that's what these 5 lines of code does. So you can say, okay, here's temperature for all the 5 cities. This is done with the graphics package called Ggplot, which is my favorite way to do static plots. I think Ggplot stands for kind of the grammar of graphics plot, and they've done a lot of work to think about how we communicate using visuals. And so if you're just getting started with making graphics, it's such a beautiful place to learn about really communicating effectively with color and shapes and facets and all the things you can do. So look into Ggplot, and you can just Google Ggplot. And if you're going to read anything about R, deployer and Ggplot are like the things to read, right? So take a look at this. There's these cheat sheets that Tidyverse put out that'll get you started. And if you're trying to communicate effectively for this hackathon, you might not be doing the most complex models or forecasting, but you can make really, really nice visuals very quickly. So look at these cheat sheets, download them, and see what you can do with them. I think you'll learn a lot just by playing around with the Ggplot itself. So what this does is I'm calling Ggplot with a data frame. So I'm passing data frame in. So I was like, okay, we're going to make a Ggplot using this data frame. And then we're using these geoms or these geometries. And I'm going to go through quite a few of these in the next, like this and the next lecture. But this is a histogram geometry. And then we call this facet wrap that uses something called a formula. I'm actually going to split this out just to explain it. So in R, there's this because R was built off of the statistical language, it has these things called formulas. So this dot means everything. Anytime you see a dot in any of these functions, it means, okay, just pull everything and then do that. So in here, for example, I could put a dot and it'd just be like, hey, pull this and do everything. And it's the exact same as had I put nothing. And that's just sort of the default. So it takes everything. In a formula, it says like plot everything against city name. So right now I just have a geom histogram that I'm plotting X temperature. But I could also, if you're doing like a stats model, you can go say, I want temp plus humidity. Sorry for my terrible spelling, against city name. And you can actually specify linear models that actually take something like that and build up a linear model. And so this, I passed a formula in, and I said, hey, can I predict temperature and humidity against city name? And what that did is it actually trained a linear model. Generally, it would be the opposite. So it'd be like, okay, I want to train temperature against humidity plus wind speed plus maybe weather main or something, right? These formulas are really nice. They're really communicative, right? So not important right now. We'll get into it, but just know that R has these formulas that you can use to do things with, and that they're quite useful when you're trying to facet and do some other things. And finally, the last thing in this is we're just labeling the X label as temperature. And so I'd recommend use Ggplot. If you're going to use R, use Ggplot to work on your hackathon and work on it that way. So go through there. Next thing we want to make sure is that we can deal with dates. Fortunately, when I was able to load the dates for both of these data sets, they behaved really nicely. We're going to use LubraDate a little bit more in forecasting, but the beautiful thing with Tidyverse and Ggplot is that they handle dates natively. So what I'm going to do here is I'm going to take weather. I'm going to filter it down so that the city name is equal to Barcelona. So I'm just picking Barcelona. So you'll see here, I've got weather, 178,000 observations, but Barcelona has 35,000. So if you take 35,000 times 5, you get kind of roughly this number. And so it gives you an idea that there's probably 35,000 hourly observations that we've made. But if I wanted to plot that and just say like, okay, well, what was Barcelona's temperature over time? Ggplot knows how to do that. So now I'm calling Ggplot with this filtered data frame, and I'm calling geomLine. So, and then there's this thing called an aesthetic. So this is saying like, hey, what do I want to plot out of this data frame? And in this, you just pass the column names. So you say like, okay, I want to plot X is date time, Y is temperature, and you plot it. So, and what you can see here is that over time, you have some pretty consistent seasonal fluctuation, right? Looks like it was pretty cold down here, but the highs look pretty much like the highs in summer. There's obviously a bit of noise, but you can see it, and it knows how to rationalize the dates automatically. So as long as you have something that's in a date format, and in this data frame, you can see it's a POSIX CT. So hopefully you guys can see that. Energy, same thing. It's a POSIX CT, which is the kind of the R Unix date time format. Hopefully that makes sense. So yeah, in this hackathon that you guys are doing, this seasonality is going to be really important to understand the problem. So I think it's really worth paying attention to, like graphing this all out and understanding things as a time series. We'll get into that a bit more tomorrow. I put a little bit more information about Ggplot here, but here is us putting weather. And then the nice thing is you can start to add layers. So if I wanted to plot weather and just plot pressure against temperature, I could do that, but you could also start adding in information so that I can see city name too. So if I plot that, the aesthetics, X is pressure, Y is temperature, color is your city name. And then once that pops up, so you take a look and you're like, oh, okay, that looks all right, but there's clearly some crazy outliers, like a pressure of 250,000 kPa would crush everyone on the planet. So I don't think that's a right measurement. So instantly you can start to get some visualizations and you can say, hey, that's only in Barcelona. So Barcelona has some funky measurements that we should probably take away. Now, there's tons of outliers in every little bit of data set. What I usually try to do when I'm trying to get a really rough feel is I'll start to do this trial and error. So I was like, okay, well, I have no idea what this should even be, but generally I'd expect that like in kilopascals, our pressure is probably going to be like 500 and 1500. So let's plot that and see. So okay, let's see that. Okay, it takes a couple seconds to plot here. Pull it out. And then what I'll do is I'll just keep adjusting these X limits until I can get a nice distribution. Be like, okay, that's what I think probably things should follow. So now you can see here that, okay, well, Valencia seems like it has a bit higher pressure. And so maybe it's a little bit lower down, closer to sea level, or something is wrong, but let's just check that out. Whereas Madrid looks like it might be a little bit higher, but given the same temperature, Valencia also looks like it's hotter than Madrid. So you can start to do that. And then you can get an idea. You're like, like that's probably an outlier. So like, once again, Barcelona has some funky data. That looks like an outlier. So maybe let's zoom in right to 900, 1100 and plot that. So generally when you're doing your data exploration, take the time to do it. And I like static plots for doing that. You could bring it into something like Spotfire or Tableau. Remy, do you know, or in the hackathon, are people using Spotfire or any type of like dynamic visualization tool?
Yeah, Spotfire is going to be a tool available to the participants for visualizations. Yeah, and yeah, it works perfectly with R, right? So
Yeah, it's good. And there's capabilities in Spotfire to like code R into it and do stuff. It can get a little bit complex. Generally, when I work with like a dynamic visualization tool like Power BI or Spotfire, what I'll try to do is I'll try to clean the data set up to show kind of what I need, and then I'll use it to dive in. So I think that you should try to use both. Definitely using Spotfire. It's a great tool. It's pretty easy to use. And once you have this data, you can start to do some of this exploration. So it's pretty okay for faceting. It's kind of its own like little thing, but it's quite a powerful tool too. So I'd recommend using both and seeing what's fit for purpose. Yeah, whatever you guys want, really.
So is this the data set that we're going to use for the hackathon?
I think so. I pulled this off of Kaggle. I might have pulled the wrong one, but I think it's the energy forecasting data set. So it may or may not be. I think they'll have to wait. Remy, I hope I'm not like jumping the gun and giving everyone a head start, but
yeah, no, it's okay. You're good.
yeah, I'm not giving away any big secrets. So I think it'll be very similar. So
Okay.
yeah, so kind of the same thing. So the next thing, I just wanted to go over a little bit more of munging. So filtering is really good. So you can filter as like, you can filter to something if it's above something, and then you can select certain columns. And so if you're doing merges and you're doing kind of some interesting stuff, I think that when we do filtering, look at deployer and look at their grammar of graphics. So homework, I guess, after this, look at Ggplot and then look at deployer. And those are like the two main packages that I think you should be using for R. And then once you get into the hackathon a little bit, I think the rest of your time should really be spent thinking about how to do kind of forecasting and kind of working on the problem, right? And then if you need a tool, R and Python probably have it built already. So just take a look and I'm sure you can find it with a nice little introduction of how to use it. So we're going to go through a little bit more data munging next time, but really these 5 verbs plus a group by get you to 95% of all of your data munging. And so if you do that, here's 2 of them. So you filter and select. That gives you your Barcelona temperature. And that's just time versus temp. And this doesn't look like a lot of code, but it's actually really powerful. So what I'm asking here is first I want to pull the date time of Barcelona temperature. And then I want to pull the total load from energy. So I want to take energy, select time, and then I'm going to rename load is like, I'm going to rename total load actual into load. So I have this Barcelona temp. It just says time and temp. And then this one is time and load. So you can see down here, time, load. And then I'm going to merge them. And generally, if you're going to be doing a lot of data munging between these 2 data sets, you're going to be doing quite a few merges. And they'll be driven by questions of saying like, okay, so do I believe that load and temperature in Barcelona correlate? And so if they do, so if you say, okay, well, I expect that as my temperature goes up, my total load should go up as well. And so you can take a look and be like, okay, does that make sense? And then we do this time series merge. So how this function can be read is we're going to merge 2 data frames, this Barcelona temperature and this total load. Each of them have a time column now, right? And so what I did here is I renamed date time ISO into time, and I renamed load from this. So I've done 2 renames in the select, and then in this merge, because they both have a time column, and the time column's roughly, it's all on the same hour, I can then merge the 2. And you'll see that this will give me 35,000 observations with 3 variables, time, temp, and load. And maybe I should rename this just to be explicit. Barcelona temp. temp. And I'm going to merge that again. So this rename is really useful when you're trying to keep stuff straight in your head. So time, Barcelona temp, and load. I'm going to take that, plot that as the X and load on the Y, and say like, okay, does this correlate? Sorry, this is quite a few points to plot, but it doesn't look very good, right? Like, so it looks like maybe there's a little bit of correlation down here, but it's definitely not a straight line. And those are the kind of plots you want to be making as you're like working through your hypotheses. Be like, hey, how am I going to forecast this? Or how am I going to solve this problem? And if you can put a question and then throw a visual, be like, oh, actually, I think if we just go temperature plus humidity plus this is going to equal the electricity load. Well, that doesn't really make a ton of sense because like this is not a very good correlation to build a model on, right? So I think maybe I'll stop there for today. Tomorrow I have another worksheet to go through where I'm going to be getting into a lot more of like the nitty gritty around sort of some forecasting ideas and some kind of power packages in R to deal with time series. So I'm going to talk a little bit more about this like grammar of data and some more munging and some transformations. I'm going to talk a bit more about time series. And then we're going to get right into forecasting. I'm going to introduce the concept of an ARIMA model and we're going to talk about time series forecasting because I think that that'll probably give you the most value out of this bootcamp. So hopefully you can attend tomorrow. We'll install some stuff, do some more data munging and go from there. And so that's pretty much everything I had for this workshop. Does anyone have any questions?
Yeah, Scott, I just have a general question, just out of curiosity. Is like R with the coding language that you started with, and that's why you like choose R over Python, or you're like familiar with both languages kind of thing?
I'm familiar with both. So I started with Python,
Right.
and then I got into R. And during my term at CNOC exclusively used R for their programming language.
Okay.
And I think that the reason why they used R is because it was driven by a couple really excellent engineers that picked up R and I was a bit more familiar with them. And then moving on to Chevron, we use exclusively Python. And the
Right.
reason for that is that it's driven a bit by our cloud service provider. And across the company, we've sort of landed on that we use Python to do most of our stuff. People do use R, but when we productionize things at Chevron, it's a little bit easier to use Python. So we do that. I guess the reason why I really love R is that it makes learning data manipulation really clear. And it really cleans it up in your head about how you do things. When we talk about Python, I think Pandas is really great for time series, but it's not as clear as R is on how you manipulate data. It's not as fast, and there's a lot of like weird intricacies with Python that can be really overwhelming and annoying for beginners, whereas R just works. I think there's like kind of this beauty in R where if I get somebody started on R, they download RStudio, and you're up and running. Whereas like Python, I need to explain a lot more and it takes a little bit longer. You need to download this Anaconda distribution. It's a bit more command line oriented and it's a bit more of a general programming language. Whereas R is just kind of this stats engine. It works really well. And out of the box, you can almost do every statistical analysis you can think of where like Python's getting there, but it's still like if you're talking to statisticians, they program in R.
Right.
Now there's a bit more of a rant, but I think both are good. Like I think most data scientists and most people that do a lot of programming are really code agnostic. They don't really care. At the end of the day, it's whatever gets things done quick enough, and it depends on how you're using it.
Does R have like similar machine learning packages, such as or libraries like scikit-learn or like
Yeah,
the
it does. Yeah, I like all my machine learning that I've done has generally been using R, and I actually like the R packages for machine learning way better than scikit-learn. They each have their philosophies, but I find the models. I'll just go over this really quickly. but I use this package called MLR. And I think it's beautiful. It's like such a well-written package. They released a new framework, but it's I don't know, it's really good. And it does everything you need for machine learning. And then there's a package called IML. And so like this IML package plays really well with MLR. And so you can get some really advanced machine learning frameworks using R. And
Okay,
I find it a little bit easier than scikit-learn, but once again, like if you know what you want to be doing, they're both really good.
right. Thank you. Thanks.
Great. Any more questions?
I just have a quick, I don't know if it's related, but I've heard people saying that you can use R more effectively instead of Excel in terms of, I don't know, building a data set or some sort.
Yeah, 100%. I hate Excel. I think it is really useful and it's done a lot of really amazing things for professionals. But I guess as an engineer with a lot of experience transitioning into programming, it's changed my life and how I think about data. And I think the reason is that you look right at the data when you're using a programming language. And I think R is a nice step from Excel. I think if you've used Excel and maybe you've done a bit of VBA, stepping into R is pretty easy. And then maybe you can step up into like TensorFlow or deep learning or all these crazy things, right? But if you look at the data and you understand how the data is structured and you really get it, you can really get a grasp on the data, as opposed to in Excel, you're always looking at sort of this formatted column, right? And you don't know if something is actually encoded as a float or if the data is actually a proper date time. And it can really be a bit limited because it looks nice, but you don't really get into like the really gritty bits of your data. And you can move through data so much faster in R. So if you take anything away from this bootcamp, whether you use R or Python, does not matter to me, but please try to use a programming language as you get into your profession, because I think now is the time for everyone to learn it. Like if you can try to learn, you don't need to be an expert at it, but if you can get good enough at this data munging and starting to build just a couple functions in R or Python, you become a superhero. Honestly, because the amount of work it takes to program something like that in VBA versus Python is staggering, the difference. So you could do something in Python that might take you months to program in VBA in a couple days. And that's based on my experience. And if you're an expert in VBA, maybe it won't take you that long, but yeah, I think definitely get into it if you can.
Okay, cool. Thank you.
Great. Well, if you guys have any more questions, you can just drop me a line. Remy, if do they have my email or anything?
Yeah, I believe we sent out an email with your LinkedIn profile, so they can contact you that way.
Yeah, drop me a message if you have any problems or anything. I'm pretty busy these days. I have a brand new baby, so if I don't get back to you, it's not personal. It's just I'm a little busy. So, but I will do my best if you have a quick question or something. If I can give you any advice on stuff, I will try my best.
Mhm.
And then if you have questions tomorrow, yeah, just ask them in our next session. So
Awesome. Well, thank you, Scott, for giving us this workshop, and we'll see you tomorrow at 12.
yeah, see everyone tomorrow. Thanks, everyone.
Awesome. Thank you.
Thank you.
Thanks.
Thanks.